Okay, hello. I'm Wojciech. This is Matt. We'll be talking about something probably slightly different. So how many of you are not working or developing stuff for robotics industry? Cool. That's probably only us here. So yeah, Matt.
Right, so we work on the Liquid Galaxy project. Liquid Galaxy is a content delivery platform, and I'll go ahead and skip to the next slide so you can see what it looks like. It's a distributed visualization thing. It's meant for immersion and showing off panoramic content, originally Google Earth and Street View, that kind of thing. Let's see, in the ladder order here. All right, so just to give you a background of what the project is, it was started by a Google engineer named Jason Holt. It was a 20% project in 2010. They brought it to us. We work for Endpoint Corporation to deploy and scale the project to all over the world and to support it and make sure it continues to grow and work properly. And the reason we're here at ROSCon is in 2015 we decided to move from just a bunch of ad hoc services and protocols for running Google Earth and working with input devices to ROS for a lot of very good reasons. You can see here, this is basically the first implementation of Liquid Galaxy. It was a while loop, while true, run Google Earth, and then you're done. Very elegant. We're trying to get back to that. But yeah, the standard Liquid Galaxy is 7 screens in portrait mode all around you, so it's 180 degrees. It's used for a lot of different things. People want to show geographic content in Google Earth, great. If we want to give guided presentations, that's totally supported. Also, a big use case is museums and public kiosks, where it needs to be up and running all the time, where a user can select content. So there's a lot of emphasis on not only reliability, but also be able to develop and deploy custom content. One of the reasons we chose ROS was it has drivers for all kinds of input devices. We're already using a space navigator, use touchscreens, leap motions, depth cameras, all those other things. Right, so we wanted to talk a little bit about hardware because we're deploying computers all over the world. Last time I checked, we're monitoring 300 individual bare metal computers, all at different sites. We're up to having full automatic provisioning of our systems, and we ship them around in these rack cases. You see this rack case here has actually 3 computers in it, an Ethernet switch for the internal network, switch PDU, and yeah, it's got wheels. Yeah, we need this for when we set up at a conference. Like if we were setting up Liquid Galaxy at ROSCon, we would just roll this in, hook up some TVs to an HDMI patch panel, and be up and going in an hour or 2.
Yeah.
So about the computers that we use, you see up there in the big orange cloud. I'm not sure why it's orange.
Internets.
Right. All of our configuration management and monitoring systems, these are all just instances co-located someplace, I think Atlanta. There's only 1 or 2 of these machines. But at each site, each physical site, there's a head node, which is a dedicated server for serving configuration and pretty much all the just utility work of the system is done by the head node. All the monitoring comes through there. And because all these systems are deployed to random networks in the world, well, we do work with local sysadmins and network people to get things up and going, but we can't rely on getting an external IP address. So we just, from the get-go, decide that all of our connections are from the system back up, and if we want to connect back to the system, it's through a reverse tunnel. But then under the head node, you can have any number of display nodes, which are computers that are connected to screens and input devices. Typically, we can do 4 screens per display node and have any number of display nodes. So you could have your 24-screen video wall or your little 3-screen mini setup. It scales very well. All display nodes boot from a read-only system image. So if something breaks, just reboot it, kill the power. We do power loss testing, so you can unplug the entire rack, plug it back in, it comes back and starts working. Like I said, we do monitoring. It's distributed in Agios, where it passively submits results back up. We feel like that will scale very well to thousands of sites. Whenever a problem is detected, it can do automatic restarts of various layers of the stack. Like a very quick reboot is the ROS stack takes maybe a second to restart and get things back on the screens. But if something's still broken, we can restart Xorg or just power cycle a machine until it's back up and running, and get emails and pager alerts throughout the whole process. And of course, we don't want to just let bugs sit out there and keep rebooting our machines. So we can always SSH in and do live diagnosis and fix the underlying problem. We end up doing a lot less of this as the project matures. One of the tools we've got for remote maintenance is LG Slingshot. It takes a screen grab of all of the screens, puts them on a nice montage, and uploads them to our monitoring dashboard.
The white rectangle on the bottom is the touch screen.
Oh yes, this is a street view experience where you can touch any of those blue streets on the map to instantly go to that location and pan the view around with the Space Navigator. But if you're SSHing into the system and want to see what's going on really quickly, we've got LG ASCII, which is the Kaka view representation of the same scene. Can you see the similarity here? Is it better like this?
It's the same image.
Like this, this, this. Right. So lots of emphasis on reliability. We test the entire stack, pretty much the entire stack. Of course, for all of our ROS middleware, we've got CatCon tests, online, offline. For our deployment, configuration management, we've got many tests to verify that the system actually matches what we configured it to be. For the read-only system image, we've got this sort of sophisticated, I guess, nested virtual boxes where the head node is on a virtual machine, then it boots up a display node and boots it from DHCP, so it does the whole TFTP.
Yeah, we are simulating 7 computers in virtual environment, basically, yeah.
Yeah, we're doing like pixie booting on some instance somewhere. And there was an interesting Selenium test we did where two browsers are launched simultaneously with Selenium WebDrivers connected to ROS Bridge, and interaction on one browser makes assertions, or we make assertions on the other browser to test this, end-to-end application level thing.
Yeah, so a few words about ROS internals. Whole product is open source. I mean, whole. The main part, which is ROS part, which takes responsibility for, which is responsible for all the logic and what you see on the and for the whole experience. There's one specific ROS node called appctl. It's not a part of the main repo where all the ROS nodes are located because it's kind of generic and low, let's say, not specific to LG ROS nodes repo. So yeah, as Matt said, ROS handles 100% of Liquid Galaxy logic and state. Everything what you get there in this product is written in ROS. The thing in the background, like the whole support structure, whole infrastructure, everything that's connected with the configuration is generated by Chef and managed by Chef, which is a super cool tool for automation and configuration management. Yeah, as I said, appctl is a generic low-level ROS node that will let you conveniently launch applications on different, in distributed environment, basically. We didn't find solution like that would suit our needs, so we wrote our own. It could be some kind of like not invented here syndrome, and we fought a lot with it to make it really reliable. But it's a really small and elegant solution. Yeah. So all the ROS nodes, there are plenty of them. Some of them are they are run only once. There's only one of them in the. They also contain, of course, many scripts, not only one. So whole stack, if you get them together, is probably about more than 100 per installation, I guess. Yeah, so something like that. So there are no specific things we should talk about here, except for the fact that we wrote our software in a such way that it's very usable. We just try to apply patterns that we use in other parts of our company here. So yeah, first slide. One of the patterns that's not really ROS specific is sending complex data as JSON. So there's basically a JSON data that publisher wants to publish on a topic, and if it's very dependent on what you want to send, if you don't really know what's the structure, you can basically stringify JSON and destringify it on the subscriber side, and it's absolutely legit. It was been working for us for a very long time. And the reason we named the message type interactive spaces messages is because there's another nice implementation of what we already did made in Java. It's a Google open source product called Interactive Spaces. It's a nice, cool framework if you like Java. Lessons learned. So as I said, we are trying to apply good programming techniques from outside non-ROS world. So first of all, we very much like dependency injection patterns. So everything that you write should be basically written in DI, so you can decouple all the things, and the logic that we have, and many ROS nodes are talking to microservices, they are talking to stuff outside, endpoints outside of ROS network, for example, APIs. We are basically doing a lot of non-ROS duty, heavy lifting in our product. So if you pass everything, for example, handle to an API or an API proxy object or whatever other non-ROS object to your class with your logic, you can very easily test it, and you can very easily mock the things that are not available during the tests when you're running the tests. Advantages, of course, are writing unit tests is simpler. Your logic is easy to observe using mocks. Mocks are actually very, very convenient if you don't have, for example, an API you are talking to from your application available at the time of when the tests are run. Code is cleaner and less monolithic and very easy to refactor. Lessons learned. So use Debian packages, of course. This is like this is kind of obvious. Keep previous versions of debs for rollback. This is also nice pattern from, let's say, e-commerce point of view, where you just quickly need to redeploy something or roll back something if it's broken. Everything should be decoupled. DI empowers decoupling, so we are doing that. Automate everything. In this kind of area, entropy can kill you. So the less entropy, the better. So everything should be as automated as possible, and data-driven, of course, to add some more buzzwords. TDD is your friend. Parameterize everything. So data driving is also a very good pattern. So here's a thing about appctl. If you ever run application from the ROS stack, it's very, very important that you close file descriptors before you actually launch it, because you'll spend 2 weeks doing this. We spend actually this amount of time in appctl, which is responsible for simply running applications on a distributed environment. Here's another listing about it. People were fighting with close FDS for a very long time. It's still not clear whether it's a bug or a feature that close FDS argument is false by default. It's probably because there's a discrepancy between different platforms, and only Linux supports this flag. It could be turned on only on Linux by default, but we also have platforms like Windows and OS X that doesn't necessarily support that. Thank you very much. No. So he asked whether close file descriptors is true or false by default. So
no,
it's.
No, he was saying that it's true in Python 3.
Yeah, it's true in Python 3. That's true.
Right, good question. Thank you.
Cool. Yeah. Any other questions?
Yeah, sometimes we just use pretty nested data structures from other things and we don't take the time to make actual message types. I would not recommend this to anybody that wants to just send JSON back and forth for all of their message types. It's a lot slower. It's not a good idea.
There's just a part of business flow in our application that doesn't send events. They are events actually, but we not call them events. They are basically describing a content that should be displayed on our product. So the JSON is just better.
Yeah, we want it to be extensible in a way that ROS messages just aren't.